You can find every security vulnerability in your application and still have zero impact if you cannot communicate what you found. Most security bugs die in two places. Either they never get filed correctly, so developers do not understand what they are fixing, or they get filed correctly but triaged as low priority because the person reading the report does not understand the severity. The quality of your security test cases and security reports directly determines whether the bugs you find actually get fixed. This is not a soft skill tangent. It is a technical skill with specific patterns that work. A security test case that lives in your regression suite is worth 10 manual testing sessions. Because it runs automatically. Because it catches regressions. Because it proves to your team that you are testing for the vulnerability class, not just checking it once and hoping. A security report that clearly explains the business impact gets escalated. A security report that only describes the technical mechanism gets closed as low priority by someone who does not understand it. In this final episode of Series 7, we are going to cover how to write security test cases that belong in your regression suite alongside your functional tests, how to write security bug reports that get action, and how to communicate security risk to non-technical stakeholders in a way that actually changes behavior. These are the skills that separate a QA engineer who dabbles in security from one who drives security improvements systematically. A security test case has the same structure as any other test case, but with some additional required elements. The standard elements: test ID, description, preconditions, test steps, expected result, actual result, pass or fail. The security-specific additions: threat category, the OWASP category or STRIDE threat type this test covers. Attack vector, how the attack is performed. Severity, what the business impact is if this test fails. And remediation guidance, what the development team needs to do to fix it. Let me walk through a complete example. Test ID, AUTH001. Description, verify that the login endpoint is protected against username enumeration. Threat category, information disclosure. Attack vector, submit a login request with a valid username and wrong password, then submit with an invalid username and wrong password. Compare the error messages and response times. Preconditions, access to a valid test account. Test steps, Step 1, submit login with valid username and wrong password, record the response message in time. Step 2, submit login with invalid username and wrong password, record the response message in time. Expected result, both responses return identical messages, for example invalid credentials, with no timing difference greater than 50 milliseconds. Severity if failed, medium. An attacker can enumerate valid usernames and target specific accounts for brute force. Remediation, return a generic error message for both cases and add artificial delay to normalize response time. That is a complete, actionable test case. A developer can read it and understand exactly what to fix. Your test framework can execute it automatically. Write all your security test cases at this level of detail. It takes more time up front and saves significant time later. Now let us talk about organizing security test cases into a maintainable suite. The mistake most teams make is creating a separate security test suite that runs only periodically. A security audit once a quarter. A penetration test once a year. Between those events, the application changes constantly and new vulnerabilities are introduced. The right approach is to integrate security test cases into your existing regression suite. They run on every build alongside your functional tests. When they fail, the build fails. The team sees the failure immediately. Organize security test cases by threat category rather than by feature. A folder for authentication tests. A folder for authorization tests. A folder for injection tests. A folder for session management tests. This makes it easy to see your security coverage at a glance and identify gaps. For each new feature that adds a new resource type, a new authentication mechanism, or a new data input point, write corresponding security test cases before the feature ships. This is security testing integrated into the development process rather than bolted on afterward. Use data-driven testing for injection payloads. Maintain a payload library, SQL injection strings, XSS payloads, path traversal sequences, command injection strings. Your test case is read from that library and iterate over it. When new payloads are discovered, add them to the library and all relevant tests automatically exercise them. Track security test coverage the same way you track functional test coverage. What percentage of your authentication flows have dedicated security tests? What percentage of your API endpoints have authorization tests? Gaps in that coverage are gaps in your security posture. Writing security bug reports that get action requires understanding your audience. Developers need technical detail. They need to reproduce the bug, understand the root cause, and know what to fix. Your report needs a clear description of the vulnerability, exact reproduction steps including specific payloads and requests you sent, the actual response you received, and specific remediation guidance pointing to the code or configuration that needs to change. Include the raw HTTP request and response in your bug report. Paste them directly. Do not summarize them. A developer can see exactly what happened and reproduce it in 30 seconds. Managers and product owners need business impact. They do not care about the technical mechanism. They care about, what can an attacker do if this is exploited, what data is at risk, what is the likelihood of exploitation, and what are the consequences of not fixing it. Translate technical findings into business language. Not, the application is vulnerable to SQL injection via the search parameter. Instead, an attacker can extract the complete customer database, including names, email addresses, and hashed passwords, using the search feature. No authentication is required. This vulnerability is well documented and tools to exploit it are publicly available. Rate severity using a standard framework like CVSS, the common vulnerability scoring system. A CVSS score communicates severity in a way that is recognized across teams and organizations without requiring the reader to assess the technical details themselves. Include a timeline recommendation. Critical vulnerabilities should be patched within 24 to 48 hours. High severity within 1 week. Medium within 1 sprint. Low within 1 quarter. If the team is not following these timelines, that itself is a process finding worth reporting. Communicating security risk to non-technical stakeholders is a skill that takes practice but follows a clear pattern. The fundamental principle, lead with impact, not mechanism. When you brief a product manager, a VP, or an executive on a security finding, do not start with how the vulnerability works. Start with what an attacker can do, who is affected, and what the business consequence is. Here is an example framing. Instead of, we found a broken object-level authorization vulnerability in the order's API endpoint where the user ID is not validated server-side. Say, any logged-in user can view the order history of any other customer. This includes order details, shipping addresses, and payment method summaries. We currently have 85,000 active customers. If this is discovered and exploited before we fix it, we face both customer data exposure and regulatory notification requirements. That framing gets action. The first version gets a nod and a deprioritization. For recurring security status updates, use a simple risk dashboard format. List open security findings by severity. Show age, how long each finding has been open. Show trend, are we finding and fixing at the same rate, or is the backlog growing? When security findings are being deprioritized in favor of feature work, present the trade-off explicitly. Here are the 3 critical and 2 high-severity findings that have been open for more than 2 weeks. Here is the type of incident each one could cause. Here is the remediation effort estimated by the development team. What is the decision? Do not make the decision for stakeholders. Give them the information they need to make it themselves. Then document the decision. That documentation matters when accountability comes up later. Here is what we covered in this final episode of Series 7. Security test cases need standard fields plus security-specific additions, threat category, attack vector, severity, and remediation guidance. Write them at a level of detail that lets developers reproduce and fix the issue independently. Integrate security tests into your regression suite rather than running them separately. Organize by threat category. Use data-driven testing for payload libraries. Track security coverage as a metric alongside functional coverage. Security bug reports need to serve 2 audiences. Developers need exact technical reproduction steps and remediation guidance. Managers and executives need business impact and risk framing. Lead with impact, not mechanism. Translate vulnerability types into what an attacker can do, who is affected, and what the business consequence is. Use standard severity frameworks like CVSS. Recommend remediation timelines. When findings are deprioritized, present the trade-off explicitly and document the decision.
That is the complete Series 7. Security testing for QA engineers.
We covered OWASP Top 10, Burp Suite, SQL injection, authentication and authorization testing, API security, the pen testing mindset, and now security test case writing and reporting.
You now have a complete foundation.
The next step is to apply it to a real application and start finding real bugs. Series 8 is next, QA leadership and soft skills. Leading a QA team, managing stakeholder relationships, and building a culture of quality.
Subscribe to QA Career Lab. Thank you for being here. I will see you in the next series.